All right, hey guys, Zach here with a brief introduction to our project. So we initially started out with the mindset to build a 5G cellular communication system. And as we met with our mentor throughout the semester, we quickly realized the broadness of this undertaking. So after much consideration, we thought it a better idea to create a framework to facilitate the development process, which research and development teams, both academic and commercial, can leverage in their own development. So we will be utilizing this framework for rapid engineering development. And up next is going to be Anwar.
Thank you, Zach. Hi, Anwar Sleman Haidar here, and I'm glad to announce that we have ironed all the technical issues relating to the installation procedure and running the Python code. First, we installed GNU Radio and the RF device drivers on Windows and Mac, as well as a couple of Linux distros, Ubuntu on a desktop and Raspbian on a Raspberry Pi. And we were able to test and verify the transmission and reception using a Lime STR connected to a Raspberry Pi. Second, the portion of the software regarding the BER, the bit error rate, which is a component of the signal to noise ratio, was completed and is now running independently of GNU Radio and MATLAB, and it was successfully demoed to our mentor last week. However, the inter-process communication between the Python code and the MATLAB scripts via object marshalling is a serious bottleneck, with each function call taking anywhere between 3 to 5 seconds. This is obviously unacceptable for a real-time system, hence the necessity of porting all the MATLAB scripts to either Python or C++ for an even better performance. But I will let Keith elaborate more on this topic. Keith?
Hello again, Keith Finch here. So as far as the hardware goes, we have this system set up and it's working perfectly. We have the USRP B210, we have the Lime STR and the Raspberry Pis. Everything's set up, we've connected them, we've tested it, and we are good to go on that front. So now we're currently working on porting out a lot of the MATLAB scripts. We're using MATLAB Coder, which will port most of it out to C++. And then we're going to kind of use a Python wrapper to kind of build in some of the custom functions that we're going to need to write. Zach wrote a modulate function for us. We're currently working on the format function and the audio read, audio write functions we're getting from the PySound file library. Those were the four necessary functions that were not supported by MATLAB Coder. And once we get that up and running, we'll be able to run our reception, our transmission, and our analysis scripts without the need for MATLAB, which will make things run smoother, faster, and more efficient. So up next is Vincent.
Vincent Barville here for our last video of fall 2020. We just finished our proposal. We used feedback from our progress report and our mentors and incorporated them into our proposal to create a more clear and defined product. That product being the framework for our communications SDR device. As my teammates have described, we've got a prototype working. Next is to definitize and work on our project and create a professional framework that people can ingest into their research teams. I look forward to working with the team on this next semester and seeing what we end up with. Thanks.